Okay, so let's review the z-values. We don't need both the positive and the negative, right? There's a positive, right, and a negative z-value. We don't need those, okay? Because the formula for the confidence interval takes care of that because it's plus or minus the margin of error. So just get the positive z-value. That's all you really need, basically. So it's because it's plus or minus the margin of error, and we can calculate the interval. Okay, so for example here, if we want a 98% confidence interval, notice the list here only gives us 90, 95, 99, right? Let's say we want a 98% confidence interval, correct? Well, that's going to be, if I get this out here, 1 minus 0.98, which is 0.2. Okay. Format, color, blue. All right. So that means the area that I need to cover is 1 minus 0.2 over 2, or 1 minus 0.01, which is 0.99. Format, color, blue. Okay, so what is the corresponding z-value? Well, that's going to be normal dot inverse 0.99 comma 0 comma 1. Oops, that should have been, I didn't do that correctly. That'll give me an approximate value. Format, color, blue. Okay, so we'll use our spreadsheet to figure this out. Right, so essentially, if we want a 98% confidence interval, all right, boom, boom, 0.98. We need to get this z here, correct? So from here to here is 99, because we have the 0.01 here and the 0.01 here, because those together make 2, which is my alpha value. Okay. Okay, so using our spreadsheet, right, normal dot inverse 0.99 comma 0 comma 1, right, that is our z 0.02 divided by 2, right, so 2.326 2.326 dot dot dot. Close enough. All right, let's say about 80% and 92%, right? So 80% would be 1 minus 80, which would be 20. And then if we want to figure out the area, we would need 1 minus 20 over 2, which would be 1 minus 10, which would be 90%, right? Or you can quickly do it in your head. 80, right? Left over is 20. Half of 20 is 10. Add that to it, you get 90, right? So essentially here, I need to do 0.90 to get our answer. So z 0.020 divided by 2. Is that what it was? Yes. Okay, so normal dot inverse 0.90 comma 0 comma 1. So 80%, half of 80 is 10. Add that to it, you get 90. 1.281, I guess. 1.281 dot dot dot. There's more after that. Doesn't matter. Use the exact value. Don't round it off. Okay, one more. So if I want 92% confidence, I need to do 1 minus 92, which is 8. Okay. And then half of 8 is 4. So that's going to give me 96. Okay, so think about it again. 92 plus the half of the 8 is 4, so 92 plus 4 is 96. All right, so I punch this here. We put a 96. and delete those. Okay, so normal dot inverse 0.96 comma 0 comma 1, close that. Right, so this is z 0.0, what did I say, 8 divided by 2, I believe, right? It's 1.7506. 1.7506, I believe. Okay. Okay, now we know how to figure out z. What we want to do is figure out our confidence interval. Okay? Okay, so let's do a question here. So the survey of college graduates collected data for 1,404 students, former students. Of those surveyed, 323 said they paid for college with student loans. Determine the 90% confidence interval for the true proportion of students that paid for college with loans. Okay, so let's make another tab here, make this bigger. So we want p hat, we want q hat, we want n, we want z alpha divided by 2. Okay, and then we'll get our confidence interval. So we'll go to our notes here. Oops. And we'll go back and copy the formula, which is right here. Okay, and we'll put her right there, and we'll do a P, and we'll center that out. That's good. Okay. So remember that this is the standard error, and the whole thing is the margin of error, correct? So we're going to put standard error and margin of error. Oops. There we go. Okay, so remember it's estimate, right? So it's going to be p hat plus or minus the margin of error, or p hat plus or minus z times the standard error, right? Because this is the standard error, and that's z, so together they make margin of error, right? Because you have your estimate plus or minus the margin of error gives you a confidence interval. Okay, so if we read the question back here, it says 323 out of 1,404 paid for college with loans. Okay, so we have 323 out of 1,404 paid for loans. So out of 323 means 1081. So 1081 out of 1,404. So notice these add up to 1, right? This plus this adds up to 1, right? Those add up to 1. That's what should happen. Then there's 1,404. That's just n. I don't know why I did that there. Okay. So z alpha 2, what confidence interval do we want? We want a 90% confidence interval, right? So half of 90 is 10. I'm sorry. So the leftover value, right? So the leftover value, the critical value, that's what we're looking for. So we need alpha, which is the significance level. Okay. So the significance level would be 10. So half of 10 is 5, so I need to do 95 essentially. So normal dot inverse 0.95 comma 0 comma 1, and there I go. There's my z alpha 2, right? All right, so my standard error is the square root of p times q divided by n. Right, so that's what this thing is right here, p times q divided by n square rooted. So the margin of error is the z times the standard error, right? That's what this is here, correct? And then there we go. Okay, so this is the sample estimate minus the margin of error. And this is the sample plus the margin of error. Okay, so I'll take these, we'll merge them. So this is a 90% confidence, 90% confidence interval. Okay? That's essentially what we have. So we're 90% confident the true proportion of students that paid for college with loans is in this interval, basically. So our sample was 23%, but the 23% is the sample, not the population. It may or may not match. It's in the interval, which means it could happen, but typically it's going to be in that interval. That's essentially what we think. Okay? All right, so essentially we take this here as what we got. So this is a 90% confidence interval. Okay, so we're 95% confident the true proportion of students falls in this interval, essentially. Okay, we'll make this blue. There we go. Okay, let's do one more here. Okay, so this one involves a ratio. This one involves percents. A survey of 1,007 randomly selected U.S. adults found that 85% respondents know how to use social media. Determine the 95% confidence interval of the true proportion of adults who would know how to use social media. So we found 85%, but that's the sample. Obviously, 1,007 is not all the adults in the U.S., so the true answer is going to be more or less than that, most likely. It could be 85, probably not. So let's take these things here, copy them to a new tab, blow this up, take the formula. Again, you don't need to copy the formula. I'm going to copy the formula so you can see it, but you don't need to do that necessarily. Okay, so I'm going to put a symbolism there, right? Because this is the population, and we're using the sample, which is the p hat, to estimate the population, right? So it said 85% know how to use social media, which means 15% don't. So whether it's a fraction or a decimal, this adds up to 1, right? Fraction or decimal, right, adds up to 1. The quantity of people in this study is 1,007. So 1,007. Okay, what is our z alpha divided by 2? Okay, so this is a 95% confident interval, right? Which means it's 5% on the tails, correct? So half that's 2.5, right? So 2.5% plus 95 is 97.5. So normal dot inverse 0.975, comma 0, comma 1, and there we go. There's our z value. Okay, so the standard error is the square root of p times q divided by n, right? That's part of the formula here, right? From the central limit theorem chapters, right? And then the margin of error is the z value times the standard error, which is that whole part there, correct? So the confidence interval is the sample estimate minus the margin of error, or the sample estimate plus the margin of error. So this merge is a 95% confidence interval. Okay, so we're 95% confident the true population proportion of adults that know how to use social media, I believe it's U.S. adults, is in here. The sample was 85, which is in this interval, but it's likely not the sample. It's probably some value that's close to it within this interval, essentially. Okay, all right, so let's bump this up a little bit here. So essentially, this is what we came up with. Okay, let's move this up. It's not moving for me. There we go. There we go. All right, so we have two basic examples here. So this is a 95% confidence interval. So that's your basic types you're going to get, is a ratio one or a percent one. Either way, These are one sample proportion, population proportion confidence intervals, right? Where we think the real answer is. Because at the end of the day, statistics is about inference. We're inferring, so this chapter 8 and 9 is all about inference. We're inferring as to where we believe the true answer is. Because statistically, we don't know unless we do a census, which is near to impossible. Or impossible to get all the possible samples. So we have to infer as to what we believe the answer to be. That's true statistics. So how do you become more confident? Well, you need more samples to increase the confidence level, essentially. And there's a question of, do you actually have enough samples for this level of confidence, which we're going to prove in the next video. Okay, so less samples is less confident, more samples is more confident, essentially, because it changes our margin of error. Okay. So the problem is, why don't you just be 99 or 100% confident? Well, 100% confident means you have all the samples. So you wouldn't be doing this to begin with. You already know what the answer is. And the closer you get to 99, the more samples you need. And samples cost two things, time and money. So there's a limitation on samples that you can get because, one, they're difficult to get a lot of times or impossible, and they're going to cost you money and time.